Hey everyone, here at Steve Morris Engines. I'm Steve, and this is an engine that we have just gotten done for Aaron Jambor out of Nebraska, right? Yep. And this is actually one of our used engines that we had here. And Aaron bought this thing, and it is a pretty bad dude. Honestly, it is a pretty bad dude. This is a All Billet 5-inch bore space. Big block Chevrolet, 632 cubic inch. This runs on methanol for race, and the third set of injectors is the street injector right there on pump gas with the pump gas system. So we have two fuel systems directly on the car right now, right this very minute. There's the methanol tank, there's the methanol fuel pump and system, and there is the pump gas system. So we're actually going to show you interesting testing in between both of them. Pump gas, and this isn't a maximum effort pump gas deal. That's just for street driving and jerking around on the street and doing burnouts and crap. It's not meant for drag racing on that small injector. We can do that, but obviously we're not for this application. So it's an interesting comparison between pump gas and methanol at these real low boost levels. Now, as you've heard me talk about before, the big cubic inch engines with big turbos on methanol always make really big horsepower and these lower nice efficiency numbers where it's just they're just in sweet spots of the map. They just really work real well. So anyways, like I said, this one has Holley EFI on it. Obviously, one other thing that this motor has, this engine actually is a titanium connecting rod motor too. Some really cool pieces in this motor. 70 millimeter camshaft, 65 millimeter camshaft, titanium connecting rods. That's a roller bearing setup. This is a drag weak setup. So fully water jacketed 5-inch all billet motor. Very good piece. One of our billet intake manifolds on it, covers, that kind of stuff. And a pair of 88s on it right now. And these are a pair of Hearts 88s. And they're working out really well. Now we're not going to be trying to make absolute max on this today, even though we probably could, but that's not really the intent of where Aaron wanted to run it at and what Aaron wanted to do. But we will show you some pretty good numbers and show you some good comparison on the pump gas stuff. So we'll run the pump gas right now on the street tune, and which is no boost, which is literally just running on a wastegate. And this has a 3 psi wastegate spring in it right now, right down there. So 3 psi. And we'll turbo smart wastegates, and we will go out, make a pull on this, and then we will just do a tune change and put this drive spud in the fuel pump. So everything is all connected right here. The fuel system is all connected except the fuel pump is not turning because this drive spud is out. So you unclamp this, quick clamp, put the hex drive spud in it, put the clamp back on, it's on methanol. Shut that pump off, put the spud in, goes on methanol. Easy squeezy. Dual fuel system. So anyways, let me put the camera down, we'll make a pull on this, and then we'll come back and put it on methanol and show you something there too. All right, now that's on that street pump, and on the pump gas. And you can see here now we're not we're gonna be running out of injector, so I'm obviously not trying to make more horsepower. And even 1300 horsepower here made it its peak up here. It kind of lays down up here because we're not throwing any more boost at it. So that'd be the nature of big cubic inch engines, where we're not ramming more air through them. As soon as it reaches a certain spot, it will just kind of naturally lay over. Because then the turbo, because we're not spinning the turbo any faster, probably technically becomes some form of a restriction. That's probably not technical, but that's just the way it processes in my head. So anyways, you can see right through here, I mean, 1,070 foot-pounds of torque up here. I mean, all the way down at 4,200, it's at 900 foot-pounds of torque. Now, what we're going to see, which is interesting, is that this is, and remember, big turbo or big cubic inch engines with big turbos make big horsepower because they're just in a very efficient sweet spot. That is at 4.5 pounds of boost. So 4.5 pounds of boost. That's pretty sweet. And for 1,341 horsepower, 4 pounds of boost, 4.5 pounds of boost. Now, what I'll show you is we'll come in and, or I'll show you what we've already done. Backtrack up here just a little bit on our wastegate pull on methanol. This is interesting. So this is the same, just the wastegates. I'll show you first the boost level. Boost level. It actually made 5.5 pounds of boost. So it makes, and it's, you know, it's 4 to 4.5 on the other. This is definitely 5.5 right here. So it is making more boost because we have more possibly exhaust flow, exhaust energy, however you want to phrase it, with methanol. So it's actually overcoming the gate. There is no pressure on the gates. So it is overcoming the gate on methanol, makes another pound of boost, but this thing is making 1,800 horsepower at 5 pounds of boost. Now always remember, this is all just, you don't just extrapolate the curve out in a linear line of, well, then 10 pounds of boost will make 3,600 horsepower, and 20 pounds of boost will make 5,050 horsepower, and it doesn't work that way. It's just in a very efficient spot in the map, of the compressor map, of where it just is moving a lot of air versus pressure. And remember, to keep you clear here, boost is a restriction number. That is not a flow number per se. It's a restriction number, how much restriction the engine is giving it, or how much restriction the air pump is presenting to the turbos. You know, if you think of the engine as air pump. So anyways, that's why big cubic inch, if we spun that exact same thing, smaller cubic inch motor, this thing would make less horsepower, because we're able to move less air at that given pressure, or quote unquote at that boost or restriction number. Okay, so anyways, very interesting. 1,800 horsepower, 5.5 pounds of boost. 1,340 horsepower, 4.5 pounds of boost. But that whole difference in methanol, so the methanol is just giving it more energy, is more. In these levels, it is just really interesting that how much different it is, and how much better it can be. So you got a fuel, you have a little bit of everything going on there. You have fuel, the way the engine's built, the way it's built for, et cetera, et cetera. There's a lot of little multiples in there, but it's just an interesting thing of more energy, more boost level, given the exact same system, tune, everything. It's just fuel to fuel. It picks up more exhaust energy, picking up boost, and picks up power. So, all right, now we're going to turn up the boost and run this like it's intended to run. All right, now this is, I'll give you a little more information here too, because obviously this is all pretty good and probably really good actually. As we can see here, 36, 37, 7800. It just starts to roll over out here, and it rolls over out here. We'll take a look at our boost. Well, it did get up to, I'm surprised, it did get up to 30 pounds of boost at 7,800. So, right where we want it to be. I think we are putting a significant amount of CO2 on the wastegate, and it's pretty much, these turbos are pretty much done right here, which is still outstanding, like really good. And always keep in mind that smaller cubic inch engine would basically make the same horsepower at a higher RPM. It doesn't just keep on extrapolating out. So pretend you put these pair of turbos and this engine right here, pretend that engine was 2,000 cubic inch with exact same turbos. It would make the same horsepower within reason, roughly, but at a significantly lower RPM, and then fall right off, because then the turbos just can't keep up. So the turbos are just falling off out here. It's a lot of engine, it's a lot of cubic inch, but that is some pretty stout numbers right there. 36, 37, it's only 7,800 RPM, but like I said, it's rolling over out there because it's running out of turbo, running out of compressor up here, and it's just, the more I can put more and more on the gate, and it doesn't do anything. It doesn't do anything. It's just out of compressor. So, but as a pretty outstanding 2460 foot-pounds of torque at 7,700, and that's a nice looking curve. 30 pounds of boost, just what we could get it up to up there. Really good. And that is going to be a super solid piece there for Aaron in a Chevy 2 street car. Pretty wicked cool. Anyways, and I know my buddy loves hearing me say anyways, so he can take another drink. Anyways, I'm Steve Morris. Have a great day.